Okay, I think we can start. So, let me make sure. Good afternoon, everybody. So, last time I told you any assembly program should have directives and instructions. Okay, for directives, I explained several directives, like for example here, area. Okay, to define one area for data and one area for code. I also end procedure, which is like a function, end of the function here. Last time I explained all these directives here, and last lab, you had one lab to understand how these directives can be used to define variables. So all of these are directives. As I said before, directives are not going to be converted to machine code. So they are not processor instructions, okay? You are just telling us it is an instruction to the compiler or information to the compiler, whatever you want to call it, okay? It's not a part of the machine code. So only two directives, I'm going to explain them now before I move to instructions, how instructions look like, okay? So one of the directives we have here, we call it equate, this one. Listen to me, equate. So how this one is used, okay, I'm going to tell you how. If you are familiar with C language, this one is exactly something like define in C language. Okay, so what we used to do in C language, you can do something like define, for example, speed 20. Okay, so what this means? It means you are telling the compiler, go through my code. Every time you find the word speed, so it should be equivalent to 20. You got what I'm saying? In other words, in your code, instead of writing 20, 20, 20, 20, you can just write speed, and compiler is going to replace it with 20. Is that okay? Why you do this way? Why you don't just put 20? For sure, there is a reason for that, right? The reason was, what if I want to change this number to 30? If I do this way, it's easy for me. I can just change one location. Once you change one location, so it's going to change everywhere in the code. You understand what I'm saying? So this was one of the motivation to do this way. So we have an equivalent statement similar to this one in assembly. This one is called equate here. How it is written and where it is written and why we use it. Number one, it is written this way. You have to put a name, any name, right? And then for sure, the name should somehow logic, makes sense, right? So for example, if this number is a speed, I have to call it a speed. If this number is whatever, so it has to be related to what number you have here. But if I do equate this way, so actually I'm telling the compiler, please compiler, in my code, every time I use this word, replace it with this number. Every time I use this word, replace it with this number and so on. Okay, guys? Okay, so someone can ask me, how we can use this one? Okay, number one, similar to the C language, okay? Similar to the example of speed. Okay, for example, I wanna define here a name, and I wanna put some value, like for example, I can say speed equate 20, for example, okay? That means every time I use the word speed in my code, it's gonna be replaced by 20. Again, what if I wanna change, I want to try a different speed, okay? Similar, for example, you have a program, I want to try different speeds. So I can make this one 30 and run the code. See if this is good for you or not, and then. So the good thing here, you can only change one location, it's going to change everywhere in your code. Is that okay? This is one use. There is a more important reason to use it, more important. What is that? I'm going to give you example to understand what I mean. Okay, look here, guys. If you wanna see the website of Tennis Tech, what do? You go to browser and you write www.tntech.com or edu. I don't know, maybe edu. I don't know. Or okay, anyway, so you have to write it is this way in English words, right? And then by this way, you can see the pitch of Tennessee Tech. Is that okay? That's what you do. Okay. Actually, the internet does not understand these letters. Okay. The internet only can understand IP address, which is a number, IP address. That is okay. That is why all what you have to do, you have to write English words this way, and these English words are going to be replaced by a number. 20, 30, whatever, a certain number. Okay. Why we did this way? Because it's easier for humans, it's easier for us to use English words than using numbers. So we have to convert it to a number. Okay, okay, guys. Exactly same thing we're gonna do right now. Okay. So what happens is that sometimes we have to use some numbers. For example, if I want to access port A, the address of port A, for example, this is the address of port A. That means every time I want to access port A, I have to use this number. Okay. For sure, it's not only one number. You have too many numbers. You understand what I'm saying? So in this case, it's going to be too difficult for us to use numbers. Okay. So what we do, we define all these numbers in one file. So in one file, we define all these numbers, and then we put English names, so that in your code it's going to be easy for me to use just English name. Okay. So if I want to get this number, just use the English name because it's easier for us. Okay, guys. So again, this is one very we use it all the time in microcontrollers, microprocessor. We use it all the time. We make constant file of constants. Okay. There are some numbers. You don't need to memorize all these numbers. Okay. Just we convert the number to English name. So all what I have to, if I want to access port A, I'm going to use the English name port A, and this one is going to be replaced by the address. So I don't need to worry about it. What is the address? Okay, guys. Again, it's not only one port. We have too many numbers. You understand what I'm saying? So that's why what we do usually, we put all this number in one file, and we use this file, as you will see now. Okay, guys. So this is for equate this way. Where we put it, as I said before, your program should have one area for code, one area for data. Okay, it doesn't matter the order, it doesn't matter. So if you want to put data here or here, it doesn't matter as long as you define this is data and you define this is code. Okay, any equate has to come here, has to be outside this area, outside, otherwise it's gonna give you error. Okay, so it has to be outside here. Okay, so there is another one. It may not be as useful as equate, or you may not even use it, but I'm going to explain it. We have another one. It's called RN here. So what this directive is going to do? This directive, sometimes I don't want to use the names of the register R0, R1, R2, R3, and so on. Or let me say it in a different way. If I want to store the speed, for example, just an example, speed, voltage, whatever your application is doing. For example, I want to store the speed in R2, right? So what I can do here is that instead of using R2, and then when you read my code, you don't understand what R2 means. So using this one here, you can, instead of using R2, for example, register R2, you can just use the word speed. And then the processor or the compiler is going to replace it with register R2. Okay, guys? So again, instead of using name of a register and you don't know what this means, I can relate it to a name, as you see here, and I can use it in the code so that when someone reads my code, can understand it better. So imagine you have code and you have R2, okay, and you forget what R2 is used for. You understand what I'm saying? But if I replace it by speed, the readability is going to be better. Anyway, it's not a big deal. If you wanna, you may not use it, but for sure this one very important. We're going to use it, especially in the future when we started to use input-output devices, because all these devices have addresses, have numbers. Okay, and we don't want to use numbers. We want to use names. That's why this one is more important. Any questions? The last directive I have right now is include. as you see here, include. So include this or get, include or get. This one, you can include the file. This is similar to what you did in C language. You can have a file and you can include it here. For example, I can create a file. I'm going to call it constants.s. Okay. So this file has all the constant defined here. So you have here a lot of equate. So if you open this file, you will find a lot of equate. Okay. All of them are defined here. So instead of every time you need to copy and paste here, every time you make a program, you need to copy paste. No, to make programming easier, you can just put all of them in one file and you just include it here. Once you do that, this is similar to copy paste. It's like you copy and paste all of them here. Okay. What I did last year, we had a lot of functions last year. So what I did, I put all the functions in one file and I asked the student to include them here. So you have to include them here. Okay. Again, so that you can use the function without copy and paste because all the functions are already included. Okay. So anyway, so again, you can think about include is something like whatever here, you are gonna copy and paste it here. Okay, guys. No, you are not. The compiler is gonna do when it during the when you run your program, compiler will do it. Any questions? Okay. I think now I'm going to move to instructions. I told you any assembly program has directives and instructions. Now I'm going to move to instructions. So any instruction, this is the general format for any instruction. Any instruction should have a mnemonic. This mnemonic should tell you what this instruction is doing: addition, subtraction, multiplication. Okay, load, store, as you will see. Okay. Also, the instruction can have a label. So this label is optional, may have a label or not. Okay. Why we may need to label somewhere? Again, label means any name, just a name. Okay. Why I need to label an instruction? This one is usually used in jump, if you want to jump. Okay. For example, if you want to do something like, I want to do something, as I'm going to explain, while loop. So here I'm going to put a name. For example, this name begin, start, any name. Okay. And then once I come to here, I'm going to write an instruction, please jump to start. So that every time I come here, I can jump it to here. Okay. That's how it is. So sometimes, again, this one is optional. You don't need to name every line. You don't. Okay. So you name one line. If you want to jump, if you are going to jump to this place, just you need to name it. Okay. This is for label. Also, you can see here for the instruction, you need a number of operands. For example, if I want to add register to register, store the result in a register, you have to tell me. So, for example, as you will see right now, this one is going to be addition, but you have to tell me this operation. Addition, multiplication, where are the source of this operation and where you want to store the result. This is what I mean by operand. So operands. So operands here means source of the data and the destination of the result after you apply this operation. Is that okay? You will see now. So also, by the way, some instructions don't need any operands because simply some instructions some instructions don't need any operands simply because it does not need. Okay, some instruction needs only one, some instruction 2, some instruction 3. Very few instructions is going to need 4. So every time I explain one instruction, I'm going to tell you how many operands are needed here. Okay, but again, operand means mnemonic means this is the operation. What operation you are going to do? Addition, multiplication, whatever. This operation needs data. So operand should tell me where is the source. Okay, source of the data I'm going to use here. Also, you need where after you do multiplication, addition, whatever. I want to store the result somewhere. So you have to tell me where you want to store the result. Also should be one of the operands here. Okay. Last at the end here, you can add comments. You have to start it with semicolon. And as I told you in the lecture, this is different. Don't be confused with C language. C language, you have to end every line with semicolon. You have to do that in C language. Here, you don't need. There is no. You don't need to end it with semicolon. Semicolon is similar to backslash in C language. So just comments. If you don't want to add comments, okay. So just remove it. Okay. You know, from any programming language, comments are not as a compiler is not gonna read them. This is just for human, not for the compiler. Just to improve the readability of your program. If you give your program to someone to understand why you made it this way. Okay. So anyway, that's what I'm saying here about the label. So this is like it is used in case if you want to do if you want to jump to this location. For sure, I don't need to say it has to be unique. Okay, you cannot define two labels with the same name. Right? Makes sense, right? Otherwise, the compiler will be confused. Anyway, so also very important, because I'm quite sure you are going to make this mistake in the labs. You should not leave a space. Okay, as I told you before, when you write your code, if it is a label, you should not leave a space. Okay. However, if it is a command, you have to leave at least one space. Otherwise, you are going to get error. For example, when I say add R1, R2, R3, if I write an instruction like this one, if you don't leave a space here, the compiler is going to tell you, I don't understand this command. Why? Because the compiler is going to think this is a label, and then it's going to look at this part, tell you this is not a valid command. You understand what I'm saying? So you have to leave at least one space here. For a label, you don't need to leave a space. Okay, guys, any questions? Very, very important thing. Listen to me. Labels. I can use label to define variables as we did before. If I go back, you will see here, for example, when this is a label, this is a label, this is a label, and this is also a label. So label means name, right? So these names can be used to define variables. Also, names, I can use it next to instructions. For example, here, that's what we do most of the time. I'm gonna show here again. Stop here is just a name, right? So here I want to keep looping here. You can use any. So what I want to say, we use labels here to define variables. Also, we use labels next to instruction if you want to jump to this instruction. Is that okay? More importantly now, okay, we use English names for labels. However, in your code, what happens is that in your code, if you use any one of these labels are going to be replaced by address. Okay, and this is exactly how can we read an array. For example, if I have an array like this one array here, okay, $. So all what I need in order to read this array, I want to know the beginning address, the first address, right? So that I'm gonna read this element, then increment it. Read next element, increment the address, and so on. Okay. So how can I get the beginning address? You have to use this name. So, and I think this was a question in the quiz. So here, once I use this word, so this word is going to give you the address of the first one, the beginning address. Is that okay? So automatically the compiler is going to replace every time you use the label. Exactly same thing here. Every time you use this one, same thing. Okay, so either a label for variable or a label for instruction. Any label is going to be replaced by address. Here, this one is going to give you the address of the first one. This one is going to give you the address of this instruction, where this instruction is stored in memory. You understand what I'm saying? For example, why we need something like that? I'm going to tell you why. For example, if I have here something like start, just again, start is not a keyword, just a name. Okay, and then I have instructions here, and then I want a branch to start. So every time I come here, this instruction is going to take me back to here. Every time I come here, this one is going to take me back to here. How this one works? Very simple. What happens is that if this start, for example, is at location 800000, for example, just an example. Okay. So what happens? Compiler is going to replace this one with the address, so that this instruction is going to take this address, put it in PC, program counter, so that every time I come here, I'm going to come back to here. Okay, conclusion. Any label, number one, we can use labels to define variables. We can use labels at the front of some instructions. In both cases, these labels are replaced by addresses by the compiler, okay? So here, this one is going to give you the address of this one, but this one is going to give you the address of this instruction, okay? And why you need to know this address to jump? Because this is where I have to jump, right? So when I put here the word start is going to be replaced by address. So if I want to jump to this location, I need this address. Okay, guys, any questions? Great. So, yeah, so that's what I'm explaining. Some instruction don't need any operands at all. Some of them needs 1, some of them needs 2, 3, some of them needs 4, maybe few instructions. Is that okay, guys? So this is the format of any instruction we're gonna write. We may put label or not. Here you have, any instruction should have at least mnemonic, at least. You got what I'm saying? But you might not have anything else, but at least you might not need a label, but at least we have this one. Okay. And then some operands. Any question, guys? Okay. For the operands here, there are several things you should know. Number one, here, operand 1, this one here, this is actually the destination register. So if you want to do, and these two, the other ones, are the source. I told you for any instruction, I need source and destination. Source means where the data is going to come from. Destination, where I'm going to store the result. You got what I'm saying? For example, I think I have one example here. For example, so here, this is a label, okay? This is a mnemonic, add. So this instruction is going to add. This is the destination is here, and this is the source. So what this instruction is going to do is this is a comment here. So this instruction is going to add these two registers, store the result in this one. So always the first one here is the destination, okay? And these are the source instruction. One more thing here, guys. Usually this one, usually it is a register. This one also usually a register, okay? The last one here, it can be a register, can be a register for sure, or it can be a immediate value, like for example, number 4, or it can be a memory location, as I'm going to explain in details now. So again, as you see here, operand 2 is a register, okay? Operand 3 may be a register. It can be an immediate value or constant, or it can be memory location, as I'm going to explain. So again, here, I told you very simple. So operands means source of the data and the destination. Is that okay? So what are the different types of operands we have? What are the different types? Okay, operands here can be a register. Okay, so if a register is a source, so I'm gonna use the number, whatever the number here. If a register is a destination, so I'm gonna write to this register, this number 1. Number 2, operand can be immediate value. When I say immediate value, I mean constant value, okay? So, or it can be a memory location, okay? Or it can be a memory location. What do you mean? I'm gonna tell you what I mean. So, so one of 3 things. For example, I want to add a register plus number 20. So in this case, number 20 is a constant value, right? Or I want to add a register to memory location, to a location in the memory. Okay, so again, operands can be one of 3 things. Any operand can be one of 3 things. It can be a register, it can be immediate value, a number, right? Or it constant number, or it can be a memory location. Okay. But before I give you more details about this, here I give you some advice, some tips about comments, how to write good comments. Okay, this is not only for assembly, this is for any programming language. For example, in order to make good comments, comment should not explain what this instruction is doing. It should explain why you are using this instruction. For example, I give you here several examples here. For example, here, yeah, this is a bad. For example, if you make a comment this way, this is a bad comment. Why this comment is bad? Because if you know assembly, you will know what this instruction is doing, right? So it's useless. You are telling me this instruction is going to add these two, store the result in R0. Okay, I already know assembly, and I can get this information from the instruction. So I don't need your comment. Yeah. So comment should not tell what this instruction is doing, right? It should tell why you are using this instruction to improve the readability. For example, I just give you one example here. Okay. So this is a bad one. Bad for what? It's bad for readability. If you give me your code, I may not be able to. Yeah, you put too many comments, but they are useless. Okay, it's not going to help me to understand your code. For example, I can say increment R2 by increment angle R2 by step size R3. For example, so now I can understand why you are using this one, because you want to increase the angle. You have a program. You have some kind of angle. So you want to increase the speed or the angle, whatever. You want to increase it by the value in R3 and so on. So here, I don't need to say that this is for any programming language. For example, here also, I have give you some examples for bad and good. So here, if you tell me increment to y, if I know assembly, I'm going to know this one means increment to y, for example. Okay, but you tell me here, this is a good way to do it. You have to say y is going to point at the next location in memory or in array. Okay, for sure, this one is better because, again, don't say what this instruction is doing. But if I know assembly, I don't need this comment. Just to tell me why you are using it. Anyway, any questions? Okay. So here, what I'm saying, we have different types of operands, as I explained. Your operand, the operand can be register. It can be an immediate or constant value, or it can be a memory location. Again, what do you mean by operand? It means source of the data. In order to do addition, multiplication, I have to get some data, right? Where you have to get the data from? I have three options. I can get data from register. Okay, so the number, I want to multiply two numbers. So I'm going to get the two numbers from two registers, for example. I'm going to multiply them, okay? Or it can be immediate value. Like that's what we do even when you say x equal x plus 2. Okay, so here 2, so here, this is immediate value. You want to add number 2, okay? Or it can be a memory location, okay? So I want to multiply two numbers. One of them is memory location. So I'm going to go to the memory location. I'm going to get the number there. Oh, this is one source of that. Anyway, so what I'm going to explain right now, if you want to, if your operand is a register or immediate value or a memory location, how you are going to use them, okay? So that's what I'm explaining. Let's start with the first one. If your operand is a register, just in this case, you have to use the name of the register. For any instruction I'm going to teach, if the operand is a register, just use the name of the register. Very easy. So that means if you see the name, just the name of the register, that means your operand is the register. For example, I give you an example here. For example, if I do something like that, add R1, R2, R2, R3. So that means I'm going to add register 2 plus register 3. I'm going to store the result in register 1. So for example, this is register 2, this is register 3, and this is register 1. So I'm going to get whatever is there. I'm going to get whatever is there. I'm going to add them, store the result here. Okay, this is what it means. So again, once you see here, guys, just the name of the register, that means your operand is a register. Very simple. Nothing is easier than that. Okay. Now, if your operand is a constant or immediate value, how I can do it? Very simple. If your operand is a constant or immediate value, you have to start with hashtag. Very easy. So every time I see hashtag, okay, or pound sign, whatever you want to call it, this pound sign, every time you see this pound sign, that means this is a number. So your operand is a number. Let's see an example here. So for example here, guys, so this is register. So here in this instruction, I need 3 operands. For this instruction, I need 3. I need 2 for the source of the data. I need 2 numbers. Add them, store the result in the third one. So I need 3. So so as you see here, this is one operand is R1, one operand R2, and the third operand is number 4. So what this instruction is doing, actually, I'm gonna get R2, whatever is stored in R2, register R2, okay? Not memory location, register R2. Whatever is stored in here in R2. Why you speak this way? I speak this way simply because just in 1 minute, I'm gonna tell you if I put here a brackets this way, here, this is a memory location pointed by R0. You understand what I'm saying? So anyway, I'm gonna clarify it. So if you see big difference between R0 and between R0 this way, R0 means your data is stored in R0. If you see something like that, as I'm gonna explain right now, that means your data is stored in memory. It's in memory. Which location? The location is stored in R0. So my data is not in R0. R0 is a pointer. The address is in R0. So I'm gonna go to R0. I'm gonna see what is this location in memory. I will go to memory. I'm gonna get whatever is stored there. Okay. Anyway, so here let's come to this point again here. So here I have 2 operands, 2 register, and 1 immediate value. So what I'm gonna do here, guys, R2, whatever in R2, register immediate value. Why I'm teaching this part? Just I want you to understand when you see instructions, any instruction, what I'm saying here is valid for any instruction. Can you know what are these operands? Very important, right? So once you see just register, that means your operand is a register. Okay. Once you see hashtag and the number, that means it's a constant number. Okay. So that means what this instruction is gonna do, I'm gonna take whatever in R2, I'm gonna add number 4 to here, and then I'm gonna store the result in R1. Okay, guys? Any questions? Very easy. Okay, very easy. It's a little bit confusing, but very easy. Listen to me. Your operand can be one of 2 things. It can be a register, it can be an immediate value, it can be memory, right? In case of a register, you just use the name of the register, as you see here. In case of immediate value, you have to put hashtag like this one. In case of memory, you have to use a square bracket this way. Very easy. So every time you see a square bracket, that means this is a memory. My data is stored in memory, but my address is stored in a register, as I'm going to explain right now. Okay, it's little. I know some students don't like the idea of pointers. A little bit confusing. Okay. Okay. So, by the way, if you try to switch these 2 together, you are going to get error, because usually the immediate value has to be operand number 3, operand number 3. So usually you put the immediate value. Any question, guys? Okay. Now let's move to memory. Okay. Memory, as you know, so that means I'm going to read a byte. I'm going to read a byte from memory, a word, half a word, whatever. Every time you want to read something from memory, every time you want to write something to the memory, you have to give me address. That's for sure. Memory, when I read or write from memory, you have to give me address. Okay. So very easy. Every time you see square brackets like this one, that means your data is memory. Very easy. Is that okay? And what we are going to do is that we are going to store the register we're going to store the address in a register, and then we are going to use the brackets. Okay. But for memory, we have different ways to express the location in memory. Different ways. I'm going to explain the different ways. If you see any one of these ways, that means it's memory. And all of them are using a square bracket, all of them, but different ways. And this is what the coming lab is about, and also the coming quiz is about. So coming quiz, I just want to make sure you understand the different formats for memory, okay, as I'm going to explain right now. So let's start with the, I already explained the idea of little Indian and big Indian, so I'm not going to go. Okay. Okay. So now for memory, guys, I told you we have how many here? 3. We have 5 formats. I'm going to explain how they are different. You should understand them. We're going to have a quiz and lab about them. 5 formats. If you see any one of these formats, that's a memory, right? So the first one here, you can use a brackets. As you see here, guys, this is one format number 1. This one is format number 2. So if you see this one, that means this is operand. For sure, I'm going to explain it. What this means. So that means this is operand and memory location operand. Okay, this is number 2. Number 3, this is another one here. For sure, you can change the number or you can change the register. So here also you can put any registers here. So here a bracket and you put one register. It doesn't need to be R0. This is just an example for R0, but you can put any other register. Okay, here you put 2 registers. You can put any 2 registers separated by comma. So if you see this one, that means for sure I'm going to explain what it means. But now I just want to give you the big picture. The other one here, okay, you can see this is one operand. It's a memory location. We have here one register, comma, a number, okay, or this one. So you can see this one is similar to this one, but it has exclamation mark, okay. So as you see here. And we have another one. This may be a little bit confusing. Okay. The third one here. So this is, sorry, yeah, this is number 3. So this is number 4. And these 2 together is number 5. Okay. So this may be a little bit confusing, but this is how, so if this together can be number 5. Now I'm going to give you details. So I'm going to go through them in details. Okay, guys. So number 1. If you see any one of this format, what it means your operand is memory, right? So you need to read memory or write to memory. So your operand is memory. This is number 1. Number 2, where is your address? That's what I'm going to explain now for everyone. Where is, because if you want to read or write to memory, you have to tell me the address. Okay, so for every one of them, I'm going to tell you where is the address. More importantly, tell me, we have different ways. Why you have different ways? Because if I want to read allocation in memory, only one way is enough. No, because as I'm going to explain now, we have different ways because usually these ones are used to read or write arrays. Okay, guys. So as you will see, but anyway, I'm going to tell you how can you use every one of them. So let's go through them one by one. But for now, I'm very clear. Okay, what I'm saying, operand can be register, can be immediate value, can be memory. In case of a register, you just use the name of the register. In case of immediate value, a hashtag and then number. Okay. And in case of memory location, should be one of these ones. Okay. So let me go through them one by one. So let's start with the first one. And the first one is called here. I'm going to read a memory and then I'm going to use a register as a pointer. I'm going to use a register as a pointer. Okay, guys. So what it means, I'm going to tell you what it means. If I want to read the location 200000, guys, for example, so all what I have to do, I have to put this location in R0, and then I am going to use R0. That's it. So if you do that, if you read, so again, don't be confused between address and the data you are going to read, the data stored in this address. Okay. So here R0 is a pointer, is a register. This register is storing address, but my operand is the data stored in this address. I'm going to give you examples to understand better. So, for example, I give you several examples here. Okay. For example, in this, and by the way, in the coming lab and quiz, I'm going to focus on this addressing modes. I want to make sure you understand these modes. I'm not expecting you understand assembly instructions. However, you need to learn 2 instructions, load and store. That's all what you need, load and store. Okay, I'm going to teach them as well here, but it's not my main focus. But for sure, I cannot explain addressing mode without at least learning two instruction. Okay, I'm going to explain for sure more instruction in the future. But at least we have here load and store. That's what we are going to use in the coming lab. Maybe you are going to have add and subtraction as well, but in this case, I give you the instruction in the lab. Okay. Anyway, but for load instruction is used if you want to read a memory location, if you want to read a word in memory, and if you want to read a word from memory and store it in a register. Okay, so load instruction is used if you want to read a word in memory, store it in register. Okay. So for let's see this example. So here load instruction. So here I'm gonna read the word from memory, store it in R1. This is what this instruction means. Okay, guys. So word, as I said before, word means full location in memory. What address? Number one, as I told you guys before. So here a word is going to be stored in full location. Do I need the 4 addresses? The answer is no. You don't need the 4 addresses. Just to give me the beginning address, which you call the base address. So if you tell me, please read the word at location 20000, what I'm going to do, that's enough. So once you do that, I'm going to read 2000, 2001, 2, and 3. That's what I'm saying. So just to give me the beginning address, and then we call it the base address. I'm starting from this base address. I'm going to read, if you are reading a byte, I'm going to read only 1 location. If I'm reading half a word, I'm going to read 2 locations. If I'm reading a word, I'm going to read 4 locations. In all cases, you're going to give me only 1 address. Confusing, right? So I'm saying, you just give me 1 address and you tell me read a byte from this address. So I'm going to read only 1 location. Read half a word from this location. I'm going to read this one and next one. Read the half a word. So I'm going to read this one and 3 more. Okay. In all cases, you just give me 1 address. Okay. Anyway, so what I want to do here, guys, is I want to, for example, here, let's see this example. At least you understand now what I'm saying, what this instruction is going to do. I'm going to read the word from a memory location, from memory, store it in R1. I read the word. Okay, which locations in the memory? The location is stored in R0. For example, look here. If R0 is storing this number, what this instruction, after you execute this instruction, what's going to happen? Okay, that means I have to read the word starting from this location. So it's going to be this one, next one, next one, next one. So I'm going to take this 4. I read the word starting from 2000. Sorry, it's not 2000. 20000000. Okay, so I'm going to read the word from there, and then I'm going to store it in R1. So I'm going to read 4 locations, store it in R1. For sure, I don't want to repeat the way I'm going to store it. Little Indian, big Indian, whatever. It doesn't matter. So I'm going to read 4 and put it. Any question, guys? If this instruction for a word, but I don't want to confuse you, but for now, this instruction for a word, if I use another instruction for a byte and everything else is the same, so I'm gonna only read this value because it's for a byte. If I use another instruction, everything is the same, but another instruction for half a word, so I'm gonna read these 2. In all cases, you are gonna give me the base address. Any question here, guys? So again, very simple. If I want to read a word from memory, you have to put the address of this word. You have to put it in 1 register. It doesn't need to be R0, guys, okay? It can be any register, and then you have to put brackets this way. Any questions? Okay. Let's see for here. So as I told you, load is used if you want to read the word from memory, store it in a register. The opposite of a load is a store instruction. Okay, a store is gonna take 1 register and they're gonna store it in memory. Okay, that's what you see now. So for example, if this is what this instruction is gonna do, very simple. So what this instruction is gonna do is gonna copy R1, store it in memory. I want to copy R1, store it in memory. Okay, guys. By the way, as I'm going to explain it, load and store instruction are similar to equal in C language. Remember when you say y equal to 2, x is equal to 7, x is equal to n. We don't have equal here in assembly. Instead of using equal, we're going to use load and store. You copy. But anyway, I'm going to give you more details later. Okay. So what this instruction is going to do, guys, this is R1. This is the value stored in R1, right? And this is the address of the location. I want to store this value in this location. Okay. When I say I want to store a word in this location, I mean this location and next. You got what I'm saying? Okay, because we agreed from the very beginning, every location you can store only 1 byte. Okay. So as you see here, what this instruction is going to do is this instruction is going to take R1, is going to store it here in these 4 locations. And that's exactly what has been done. I stored it this way. Any questions? Okay, guys. Okay, the coming lab. In the coming lab, I'm going to ask you to write 5 programs, okay? So don't be scared. They are very small, very small program, very simple, okay? And even I almost give you the answer, okay? Just to make it easy because you're still in the beginning, okay? So I'm telling you, write an instruction to do this, that. So I give you some details. But anyway, so in one program, you have a memory location called number 1. So here you have a memory location, it's called number 1. You have another memory location called number 2. For example, number 1, I'm going to ask you to define it, DCD, whatever DCD, and then you put here some value, BB, whatever. And what I want to do here in this program, so now in this program, I'm giving you two memory locations. Every one of them is a word. And what I want to do, I want to swap them. So that means after you run your program, this value has to come here and this value has to come here. Okay. How can you do that? Very simple. You know, if I have a number here and I have a number here and I want to swap them, how I can do that? I told you here, you can use, for example, register R0, R1. So I can read this one, put it here. I can read this one, put it here. Okay. And then I'm going to use R1, put it here. So this can be number 1, number 2. So number 3, R1, put it here, R0, put it here. So all what you need, load and store instructions. You got what I'm saying? So here I'm going to read this number. I'm going to put here in one register. I'm going to read this number, put it here using load instruction. And then after that, you are going to use store to store this one here, store this one. But there is a problem here. What's the problem? In order to read the memory location, I need the address, as I said. So I have to use a pointer. For example, if I have here, for example, if you have here number 1, DCD, whatever, okay. So I told you I want to read this value, put it, for example, in any register, for example, R0, okay. So how can we do that? That's what I have just explained right now. But there is something is missing. I'm going to explain it now. So what I can do, say here, I can say load register, and then I can put here R0, for example. Okay. And then here, I have to put the address here should be similar to number. Is that okay? Here, I'm going to read a word from this location, put it in R0. Is that okay? So how can you do that? You have just told us right now, I have to put here a register. Yeah, for example, I put R4, for example. Okay, yes. So what is missing here? This one is gonna work? No, this one is not. Something is missing here. What is missing? I have to put this address here in R4. So before I use this one, I have to put the address, this address, I have to put it in R4. You understand what I'm saying? because inside the brackets you have to put a register. The location you want to read, you have to put it in a register. And then you have to put the register inside brackets. Is that okay, guys? So how can I do this step? I'm going to tell you how, and we did it before, but just to remind you. For example, I can say load R, and they here R4, comma, and then I put equal number 1. I think we used this instruction before. What this instruction is going to do, this instruction is going to take the address, the beginning address, which is 2000 in this case, is going to put it in R4. Okay, guys? So number 1, I want to read location. So number 1, you have to put the address of this location, you have to put in any register. Number 2, I'm going to use this register inside brackets. Easy, right? Can I just, instead of doing it, can I just put here the address inside here? Can I do that? No. This is how it is made. It has to be inside the register. Okay, number 2, how this one is going to put address here? Simply because, as I told you, when you use a name, this name is going to be replaced by address. You just use a name, but the compiler is going to see this name, this one, which location you mean. It's going to replace this one with address here. And this instruction is going to take whatever he put it. Any question, guys? If you want to me repeat, let me know. If anything confusing, let me know. Okay, guys? Okay. So here I give you also another example. Again, remember, I'm here. I told you for memory we have four different ways. This one, this one, this one, this one, and this one. So I'm still here. Okay, guys? Okay. So now I also want to tell you, also maybe this is not the best one to use if you want to read array. For arrays, this one may not be the best, but it can work. It can work. I'm going to tell you why for now. So I want to give you this example. If I want to use this format for array, how I can do it. And then I'm going to tell you the main idea. The main idea, look here, guys. If I have array of words, okay, that means here every four bytes, I have one element. I have one element every 4 bytes because it's array of words, and then another 4 here, and then another 4 here. And the first address here, we call it the base address, the base. Okay, so what we can do, if I can put the base address, if I can put it in R0, for any R, guys, don't be confused, any R as a pointer. So I'm going to use R0, R1, whatever, as a pointer. I'm going to put the base address here. Is that okay? And then if I do here R0, for example, R1, and then I say load. So this one is going to read the word from the location pointed by R0, put it in R1. Is that okay? Actually, what I did, by this way, I can read element number 0, the first element. Let me ask you a question. Hopefully someone can answer me. If I want to read element number 1, what can I do? I already read element number 0 by this way. Okay, now I want to read element number 1. What should I do? Someone should answer. Is that too difficult? What I have to do, I have to move this address to here. Is that okay? So what I have to say, R0 should equal R0 plus 4. For sure, this is not assembly, but I have to do something like that. I have to add 4. Once you add 4, I can repeat this one again. Load R1, okay, R0. Okay, yeah. So this is the way I can do it. I can R0, for example, I can use one register like R0. I can use it as a pointer. In the very beginning, R0 is here. And then I'm going to read the word pointed by R0. This is element 0. Then increment R0 by 4, and then read the word pointed by R0. This will give you element number 1 if I start counting from 0. Same thing again, add 4. Once you add 4, so every time you add 4, you actually is gonna point to a new element. Is that okay, guys? What if this is array of half words, not words? Every time I have to add 2. What if this is array of bytes? Every time I have to add 1. Make sense? That's it. So what I did, guys, very simple. R0 pointing at the beginning address of the first word. I'm gonna read it. Then I'm gonna add this 1, 2, 3, 4. I'm gonna add 4. Okay? R0 is gonna be here. Then I'm gonna read 4. 1, 2, 3, 4. Okay? Then it's gonna be here. So every time you add 4, you are gonna point to the beginning address of a new element. Okay, guys? Yeah, you can do this way to read an array. Yes, read or write to an array. So that's exactly what I did here in this code. So I want to do something similar to this one in C language. So here I'm assuming I have an array. Okay. And then for every element in this array, I want to add 5 for every element. So I'm gonna read this element, add 5, and then store it back, as you will see right now. Look how I made it. Okay. In the very beginning, so I have here array. As you see here, guys, I have several elements. R0 is pointing here. We assume this is the beginning address. So R0 is pointing here. Okay, so I'm gonna read this one. Then I have to add 4, read this one, add 4, and so on. So let's see how I made it. So the way I made it, here I'm gonna read element 0. As you see here. Here I'm gonna read element 0. I'm gonna put it in R1. And then what this instruction is gonna do, I'm gonna add 5. So I'm gonna read the number stored in R0, and then I'm gonna add 5 to it. Then I'm gonna return it back to memory. Why? Because that's what I want to do. I want to add 5 to each element. I want to add 5 to each element. So this is how we're going to do it in assembly. Listen to me. That's what I'm going to explain, guys, later. We don't have instruction to do a direct addition to the memory. We don't have hardware to support that. The hardware cannot add 5 to memory directly. Why? We don't have hardware to do that. The way you are going to do it, number 1, I'm going to read location in memory, do whatever you want to do, and then return it back. So load, process, store. Why? Simply because the ALU is not connected to memory. It's just connected to registers. So that's what I did. So number 1, as you see here, I'm going to read one element. Then the value of this element, I'm going to add 5 to the value of this element. Then I'm going to store it back in memory. Any questions? Should understand this one so that the coming lab will be easy, fun, if you understand this one. Okay, so now I am done with the first element. Okay, so now I want to work on the second element or element number 1. What should I do? I'm going to repeat the same code. I'm going to repeat the same code here, as you see. The same code, I'm going to repeat it. However, you have to update R0 because R0 was here, so you have to add 4. That's exactly as you see here. Look here, guys. So this code is similar to this code. All what I did, I updated R0. I added 4 to R0 to work on element number 1. Then I did it again. Then I did it again. Every time I add 4 to the address to get a new element, for every element, add 5, return it back. Load, 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 addition, store. Update the address. Number 1, update the address. Get the element, add 5, store it back. Any question, guys? Okay, so this is how can we use this approach if you want to read memory. This might not be the best way, but it works, so it's okay. Okay. By the way, what if I have 100 elements? Should I repeat this code 100 times? For sure, no one does that, right? That's why they invented loops. So actually, as we are going to teach later, we can have loops so that in every iteration in the loop, you are going to work in one element. Anyway, now I'm going to move to the next format for memory. So the next format, as you see here, look, guys, this is I'm done with this one. Okay, now I'm going to explain this one. So here, as you see, we have brackets, similar square brackets similar to this one, but the difference is that this one has two addresses, but this one has only one address. Sorry, this one has two registers. This one has one register. I'm sorry. Okay, guys. Again, for any memory format, you have to ask me what is the address, because all this memory format should give me address. In this case, the address was inside R0, whatever inside R0. In this case, the address is actually R0 plus R3. So in order to get the address, if you want to read a word from here, so this instruction is gonna add the values of R0 and R3 without changing R0 or R3. I'm not gonna change them. I'm gonna just read this one, add them together, I get the address without changing R0 or R3. Okay, guys? So again, all what I did here, the address is stored in one register. Here, the address is just split in two registers, right? And then in order to get the address, I have to add them together. Why they do that? It doesn't make any sense. Why you split it in two registers? For sure, there is a reason. Okay, what is the reason? I'm going to tell you what is it. The reason is that one of the addresses, okay, as I told you guys, if you have here, for example, here we call it the base address. Okay, so this is for one element. This element should be the base address plus 4. Okay, this one should be the base address plus 8, right? Because 4 and 4, 8. Is that okay, guys? Okay, so by using two addresses, two registers, I can do that. By using two registers, I can do that. I can put the base register in one, I can put the base address in one register, like R0. So the base in R0, okay? And I can use the other register as an offset. As an offset. Okay, what do you mean? Okay, what I mean, R0, I'm gonna put the base address. I'm not gonna change R0. I'm gonna keep it the base address. Now, I told you this is R0 and R3. Now, R3. If I put 0 in R3, so I'm going to read element number 0. If I put 4 in R3, so I'm going to read element number 1. Okay, so here, so one is going to have the base address, the other one is going to be offset to move it from here to here or from here to here. You got what I'm saying? So yes, so I can do this way. So I can use two addresses. In one address, I'm going to put the base address. The second one is going to be offset. If the offset is 0, so I'm gonna get this element. Base address plus 0, I will be here. I'm gonna read this one. Base address plus 4, I'm gonna read this one. Base address plus 8, I'm gonna read this one. Base address plus 100, I'm gonna read the element number 100. Very easy. No, sorry, 100 times 4. I'm sorry, right? Because if it is every time you have to add 4. So if I want to read element number 1, so it has to be 4. Element number 2, it has to be 8. Element number 10 has to be 80. Yeah, sorry, 40. Because every time you add 4, 40. Okay, guys? So anyway, so yes, I can use one of them as a base address and I can use the other one as offset. So you should understand what I mean by the word offset. Offset means you add something so that you can move from one element to another element. Is that okay? So now I'm going to show you how it works. Also, I'm going to give you example like this one to understand it better. So yeah, that's what I'm saying here. Yeah. So let's see, for example, if I want to do the same thing using, if I want to read this array, the same example here. Here, I'm going to use R1 and R2. Okay. Again, it doesn't need to be R0. Okay. Okay, it can be any register. So here, R1 is going to be the base address. So the base is going to be R1. R2 is going to give me, so R2, this one should be 0 for element 0. It should be 4 for element 1. It should be 8 for element 2, and so on. Okay, that's exactly how I'm going to do it. Look how I'm going to do it. So in the very beginning, I'm assuming the offset is 0 and the base address is here. So once I read here, so by this way, I'm going to read element 0. After I read it, I'm going to add 4, and then I'm going to store it back. So I read one element, add 4, return it back. Okay, so this is for one element. Before I move to the next element, this is the next element. Look what I'm going to do, guys. Now I'm gonna add 4 to R2. So now R2 is 4. The offset is 4, right? And then now it's gonna be 4 plus R1. 4 plus R1. So this one is gonna point at element number 1. Also, I can add 4 as well. So a good thing about this approach, guys, if I want to read, I don't need to read like one by one or in sequence. I can just read any one. As I told you, if I want to read the element number 10, so I have to put 80 here. I have to make sure this one has 80 in order to read the element number 10. I'm sorry, 80 what? You have to tell me something, guys. 40, right? So yeah, 40, because every time I add 4. Okay. Any questions? And if this is array of bytes, it would be different if it's array of bytes. So every time I have to add 1. If it's array of half words, so every time I have to add 2. Here I add 4 because this is array of words. Every element is a word. Okay. Any questions? Okay. Let's move to the next ones here. So I just for the coming lab and quiz, all what I want you to understand what I'm explaining, understand the examples. If you understand all of that, everything should be very easy, right? So now I explained how can we use this one, what this one means, how can we use it, even how can we use it to read arrays. Okay, this one I explained how can you even use it to read arrays. Now there is another approaches here. Okay, these approaches are called, this is register offset. Register offset. Why? Because the offset I store it in a register. I put the base address in one register and the offset in a register. The other approaches we have here, we call it immediate offset. Because all what I'm going to do, instead of using another register as an offset, I'm going to use immediate value as an offset. You will see it right now what I mean. Okay, guys? So let's go through them. But again, so this one is similar. This one is similar to this one. You have base address and you have offset. But the difference is that this one, as you see here, the offset here is constant, not a register. Okay, let's see what this format means. And again, this is a programming. You can just use one of them all the time, but still you need to learn all of them. Maybe you are gonna find something interesting here, as you see. For example, this two has something very interesting. Okay, what is that? If I go back here, you can see, guys. Yeah, if I come to here, you will see every time I have to update, I have to use this instruction to update the pointer, right? Same thing here. Every time I have to use this one to update the offset. So every time I have to use one instruction to update it. Okay, but as I'm going to explain right now, this one is done automatically. You don't need to write, as you see here. So what this instruction actually is going to do two things. It's going to read and update the pointer as well. Yeah, so this one may be interesting because I don't need to write an instruction to update the pointer. You know what this one looks like in C language? I'm going to tell you before I take this question. You remember in C language when you did something like I or y, for example, equal I plus plus, or y equal plus plus I. This is almost something like that. You were told in C language, this instruction actually two instructions, but in one instruction, two instructions. So this one should do assignment, y is equal to I, and it should update I, incremented by 1. Okay. So the two instructions is going to do these two operations. The difference between them, which one I have to do first, the order. So they told you This one is called postfix. Sorry, it's post increment. Post. That means this one should be done first. I'm gonna assign first and then increment, right? This one is gonna be the opposite. So it's gonna do this one first and then this one second. Okay, guys? That's exactly what I'm gonna do right now. It's one instruction, it's gonna do two things. It's gonna read, update the pointer in one instruction. Okay, guys? So again, what I did using this format, still you can do it using format I'm gonna explain right now. But actually, you may not need this one, as I'm gonna explain. So again, there are different ways, but I can use any one of them. So maybe one of them can replace others. Maybe one of them is more interesting than other. Maybe some of them are like more efficient because you don't need to write two instructions. You can just write one, as you will see it now. Okay. Yes, you have a question?
Yeah, I was just wondering on that slide that showed the post and pre-increments. Is the exclamation point what would carry out the update? Because I noticed that on the pre-text.
What is this one?
Exclamation point, I want to know, is that what carries out the update, or what does the exclamation point do? Because I know how we said, usually in C we end with a semicolon and and this is for comments. So I was wondering, what is the purpose of an exclamation in the frame of this?
Okay, so I'm gonna explain right now. So as you see here, this one, for sure, this one is different from this one, right? This one you have two registers, very clear. But this one has a register and then a number. If it is array of words, I'm gonna use number 4. If it is array of bytes, I would use number 1. If it is array of half words, I would use number 2. Okay, this number 1. Number 2, this one is similar to this one, but the only difference is this one has exclamation mark. Okay, just to differentiate between them. This one is somehow different. So here I get this one outside. So I move this one here, I remove this one. So at least you can see the 4 are different, right? So this one is not an operator. You got them. It's not something like plus I. It's not operator for something. It's not like that. Okay. This is a part of the format. Just differentiate between this one and this one. I know what confusing you. You thought it's something like an operator, like for example, something like that or any other operator. No, it's not an operator. It's just a part of. So let's see how they are different. How can we use them? So let's see the first one here, guys. Look, what this one is doing is that number 1, the difference again. All of them are memory. Agree on that. So here I'm gonna read a memory. I'm gonna read a memory. I'm gonna read a memory. So all of them are memory. And I know this may be confusing because every time you see comma, you may think it's 2 operands. But no, this is, once you see something like that, this is just one operand. Okay. So you are going to read a word from here, a word from here, a word from here. So all of them are memory. So that's okay. You are going to read a word from memory. The difference is in the address and also in the updating of the pointer. For example, here in the first one here, the address is, so I'm going to read the location R0 plus 4. And this one does not change R0. Okay, so this one here, R0 plus 4. And this one does not change R0. Next one here, this one is going to be R0 plus 4. This is the address. This is the address I'm going to read. And this one here, this one is going to update R0 first. So it's going to increment R0 by 4. And then it's going to read the location pointed by R0. Okay. This one exactly same thing, but it's going to read first. It's going to read the location pointed by R0 and then increment R0. Look here again. These two are the same thing. Okay. The difference is that this one is going to update R0 first by adding 4, and then it's going to read the word from the location pointed by R0. This one here, I'm going to read first the location by R0 and then update R0. Okay, guys. Okay. If I want to read an array, how I would use them differently? I'm gonna tell you. Let's start with the last one because maybe this is the easy one, and this is the most efficient one. Look here, guys. Number 1. If I have an array, for example, I'm going to say array DCD whatever. I have array here. Number one, you have to put the base address in R0. So I have to say load R, and that's what you are going to do in the coming lab. You have to say load R0 comma equal array. Okay, so what this one is going to do, this one is going to read the base address, put it in R0. So R0 is holding the base address. Is that okay? After that, if I want to read element number 0, all what I have to do, I'm going to use this instruction, load R1 comma R0 4. So this one is going to give me element 0. Why? Because this one is going to read a word from the location R0. Okay, guys? And R0 is pointing as the first element. So I'm okay. R0 is pointing as the first element, and this one is going to read a word from location R0. I'm happy, right? I'm okay. Now, this is the interesting part. Now, what if I want to read element number 1? You don't need to do anything for the pointer. Pointer is already updated for you. So all what you have to do, just to repeat this instruction. You have to say load, for example, R1 or R2, whatever, R0 and 4. And then use it again. That's it. So every time you use it, you are gonna read the next element, and you don't need to write an instruction to update R0 because this instruction will do that. Any question, guys? Anyway, read it because I'm gonna complete it next time, and then we are gonna have a lab on this one. Okay.